Chapter 4, System Unit. In a desktop computer, most of the electronic components are housed in an enclosure called a system unit. These units can be made of steel or aluminum or plastic. They used to be almost always painted gray, but other colors have become more common recently. Within the system unit, there is a main printed circuit board, PCB, called the motherboard. The motherboard holds many of the electronic components of the system, including the CPU, memory, and the board itself supports communication between the various units, the various components. It also provides connectors for other peripherals. The term motherboard specifically refers to a PCB with expansion capabilities and will typically have a number of components attached to it. The central processing unit, a CPU, is the electronic circuitry within the computer that carries out the instructions of the computer program. It performs the basic arithmetic logic control and input-output operations specified by the program instructions. The CPU will contain principal components, an ALU, arithmetic logic unit, processor registers, and a control unit. Most modern CPUs are microprocessors, which means that they are small and they're contained on a single integrated circuit chip. Modern microprocessors are often described as being 8-bit processors, 16-bit, 32-bit, or 64-bit. The number can refer to the number of data lines in the data bus. That's how many bits can be transferred simultaneously. It can refer to the number of bits in a processor register, which describes how many bits can be processed simultaneously, or the number of bits in the address bus, which describes the maximum size of primary storage that the computer can support. Now, at the moment, most personal computers have 64-bit processors, 64-bit in all three senses. Some microprocessors are described as being dual core, quad core, or some other higher number core. These processors have 2, 4, or more processing units in the same CPU chip. Having multiple cores, multiple processing units, the computer can do several operations simultaneously. And of course, that allows it to process faster. There are several common ways to describe how fast a processor operates. Hertz or megahertz or gigahertz, MIPS, million of instructions per second, flops, floating point operations per second, gigaflops. Hertz describes the clock speed of the processor. MIPS, million instructions per second, describes how fast the processor executes instructions. And flops or gigaflops describes high performance computing speed. There are two classes of processors, RISC and CISC. The reduced instruction set processors, RISC processors, use a smaller reduced instruction set. The design strategy is based on the idea that a simplified instruction set can provide higher performance, faster execution. The simplified instruction set is a simpler architecture that allows your CPU to be optimized to execute these relatively few instructions much more efficiently. Complex instruction sets, computing CISC processors, use a design strategy based on the idea that with a larger instruction set, you can write programs using fewer instructions. And with fewer instructions, the programs would execute faster. Memory refers to the hardware used for storing information for immediate use in the computer. Memory, primary storage, main memory is generally implemented using semiconductors, and the memory is addressable. Most of the memory consists of cells, each cell storing 1 bit of information that can be represented as a 0 or a 1. Memory cells are grouped together into words. Typically 8 bits in a word, or 16 bits in a word, or 32 bits, or 64 bits, or in some computers, 124 bits. Each word is assigned an address, a number. The word and its contents represented the information it represents can be identified and accessed using that number, that address. Most common form of computer memory is called random access memory, or RAM. It's considered random access because each word in the memory can be accessed, identified without accessing other words first, can be accessed directly. Some authors refer to this as direct access, since each word can be referenced directly. Random access is more common, more traditional. As we said earlier, each word in memory has a unique address, a number used to identify word in order to read or modify its contents. An address, the number, has a binary representation of a fixed number of bits, n bits. N is determined by the CPU and the address bus of the motherboard. Common values for this number n are 32 and 64 in the more recent microcomputers. And that makes it possible to store 2 to the 32 or 2 to the 64 words in memory. There is currently a great deal of interest in what they call quantum computing. Quantum computing works a little differently than traditional computing. Common digital computing, traditional digital computing, requires that data be coded as binary digits or bits, each in one of two distinct states, represented as a 0 or a 1. Quantum computation uses quantum bits or qubits, and qubits can be in a superposition of states. Large-scale quantum computing would, at least theoretically, be able to solve certain kinds of problems much more quickly than would classical, traditional computers. They might then be able to break many of the cryptographic systems in use today. Quantum computer derives much of its processing power through the ability of bits, qubits, to be in multiple states at the same time. Superposition of states. They can perform tasks simultaneously. Quantum computing currently is more theoretical and experimental than actually doing applied computation. But there are a number of companies that are investing heavily in it. Atom Computing, Xanadu, IBM, Cold Quanta, Zapata, D-Wave, Strangeworks. An instruction cycle, or fetch, decode, execute cycle, is the basic elementary operational process for a computer. Different CPUs have different cycles based on the different instruction sets, but generally they're all pretty much similar to the following: fetch an instruction, decode the instruction, obtain any necessary data, execute the instruction, store any resulting values, then fetch another instruction, decode that instruction, obtain the necessary data for that instruction, execute the instruction, store the resulting values, and do it again and again and again until the computer shuts down. A computer program is a sequence of computer instructions that the processor can execute, and as it executes them, makes the system do something that the user or programmer wants it to do. The processor executes a program by performing the instruction cycle we just described again and again until it's executed all of the instructions in the sequence. That means, of course, that these instructions have to be stored in computer memory for the processor to access them, have to be stored as codes for the instructions. And that, of course, means that all of them have to be represented in a binary format, because that's how computer memory stores things. The collection of all the binary codes for all of the instructions that a processor can perform is called the machine language for that processor. A program in the form of binary instruction codes is called a machine language program. Humans would deal with the machine language programs as long lists of binary numbers. And of course, binary numbers are difficult for humans to deal with. In order to facilitate the construction of computer programs, make it easier for humans to actually create them, programming languages were developed using text representation for the actions for the computer to carry out. Of course, computers only process instructions in the form of the electronic representations of binary codes for these actions, so the text representations have to be converted or translated into binary representations for the corresponding processor instructions. The first languages that were developed for controlling computers consisted of just assigning a text code to each instruction that the processor was capable of executing. These text codes would typically be designed to indicate what kind of an action was to be performed. Add, to add two numbers together, subtract, move, so on. Such a collection of text codes is called an assembly language, and a program written these codes is called an assembly language program. The text codes would be translated or converted to the associated machine language instructions, binary codes, by programs called assemblers. Assembly languages, of course, are designed for specific processors. They're characterized by the property that each assembly language code corresponds to a single instruction of the processor. Assembly language programs tend to be long, complex, and difficult to debug and maintain. In addition, an assembly language is designed for a specific processor. The programs have very limited portability. A program written for one kind of computer probably couldn't work on another kind. It's difficult to transfer a program from one computer to another. High-level programming languages then were developed to address these issues to make writing the programs for computers easier and more efficient. In a high-level language, as opposed to an assembly language, a single command would commonly require several processor instructions to carry out. Thousands of high-level programming languages have been designed. A few of the more commonly used, more widely used, are Fortran, COBOL, Lisp, BASIC, Pascal, C, and Java. Instructions in text form have to be translated into machine language. Binary codes for the processor before the computer can execute them. This kind of translation will be done by programs, by some would be called assemblers, or compilers, or interpreters. As we mentioned above, an assembler is a program that translates an assembly language program into machine language binary codes. A compiler is a program that translates a high-level language program into a machine language program. An interpreter is a program that translates instructions in a high-level language into machine-level language, into machine language instructions. Then it executes the machine language instructions, and then it translates another high-level language instruction into machine level instructions and executes those. It translates and executes, translates and executes one high-level language instruction at a time. Programs that are executed by interpreters tend to run more slowly than compiled programs, since with an interpreter, an instruction has to be translated every time it gets executed. With a compiler, the translation is performed only once, so that in a loop, in instructions that get executed several times during the execution of the program, they have to be translated several times while the program is being executed. On the other hand, interpreted programs tend to be easier to debug, since when an error occurs, it's easy to identify the source code where the error occurred. Cache memory is random access memory, RAM, that the microprocessor can access more quickly than regular RAM. Cache memory, then, is fast. It can be accessed very quickly, but it's expensive. Traditionally, cache memory is categorized in levels, describing how close it is, how accessible it is, how fast it executes. Level 1, L1 cache, is the fastest. It's extremely fast, but it's extremely expensive. It tends to be implemented relatively small amounts, but normally it's built right into the processor chip. Level 2 cache, L2 cache, comes in larger amounts, is input in larger sizes than in L1, because it uses technology that is cheaper than that used for L1 cache. Level 3 cache, L3 cache, can be even slower than L2, but it's usually still much faster than RAM, regular RAM. There are two distinct kinds of random access memory and read-only memory, RAM and ROM. Data items can be read from RAM and ROM, either, but you can only write data into RAM. ROM is implemented using non-volatile memory. RAM is not associated with volatile memory. Most home and office computers have their operating system on magnetic drives, hard disk drives, and only a minimal hardware initialization core and bootloader in ROM. The loader is known as the BIOS in IBM-compatible computers. When the computer starts, the program loads the operating system into RAM. The operating system runs from RAM rather than ROM because instructions in the operating system are executed very frequently, and ROM access is slower than RAM access. This allows operating systems to be upgraded relatively easily, since the modifications can be made on the program stored on disk. There are, in fact, several different kinds of RAM, some of which are faster than others, but are more expensive and use more power and generate more heat. Those are faster kinds of RAM are typically used for cache memory. Complementary metal oxide semiconductors, CMOS, is a type of integrated circuit that requires very little power. It can store data and execute simple instructions, typically keeping track of time and system time and date. It uses a very small battery that provides power it needs to operate. Since it uses very little power, the batteries last a long time. CMOS has been used on motherboards for a long time to store BIOS instructions. It's falling out of fashion on modern computers. It's being replaced by the same technology used for solid state drives. The primary function of computers is information processing. That does include numerical computation, but a lot of other things as well. In order for the computer to process information, the information has to be represented in a form that the computer can handle. That means binary format. For many reasons, computer designers have come to use binary equipment to store representations of data. For one thing, binary devices are simple and cheap to manufacture. In addition, it's less error prone because distinguishing between two states is easier than distinguishing between multiple states. The use of binary equipment requires that the information be represented in binary form as sequences of zeros and ones. Although this is convenient for digital equipment, binary representations are problematic for humans. Humans have difficulty distinguishing between different sequences of binary digits, even recognizing whether two sequences have the same number of digits is not that simple. Not that it is easy to make a mistake. This then can lead to errors when humans are dealing with information in binary format. To help with this problem, it has become common to represent data in a hexadecimal system, 16 digits. The digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. They can use uppercase A, B, A through F, or lowercase A through F. These digits can each be represented using 4 binary digits. 0000 for 0, 0001 for 1, 0100 for 4, 0110 for 6, 1000 for 8, 1010 for A, 1011 for B, up through 1111 for F. These are relatively easy to convert from binary to hexadecimal or hexadecimal to binary. The sequence 1011 B 0001 1 0000 0 0101 5. The hexadecimal sequence 90A9 could be represented with the binary sequence 1001 9 0000 0 1010 A 1001 9. Of course, we also expect our computers to process text data. And so, characters, letters, digits, punctuation symbols, and so forth, have to be represented, as well as numbers. One of the earliest and still one of the most commonly used systems for representing characters, letters, digits, and so forth is ASCII, American Standard Code for Information Interchange. Originally based entirely on the English alphabet, it has codes for 128 specified characters using 7-bit integers. ASCII codes use 7 bits, so each character can be represented as the content of an 8-bit byte with an extra bit left over. The extra bit in some systems is used to extend the ASCII system to represent more symbols or characters. But there are several different ways this is done, no uniformly accepted way. More common use of the extra 8th bit is for error checking. Of course, many languages use symbols or characters that are not included in the ASCII coding system. Unicode was developed to allow people using these other languages to make use of computers as well. Unicode is a computing industry standard set up to include text expressed in most of the world's writing systems. The latest system of Unicode contains more than 128,000 characters, covering 135 modern and historic scripts, as well as multiple symbol collections. The Unicode standard defines Unicode transform formats UTF-8, UTF-16, and UTF-32, as well as several others. The most commonly used are UTF-8 and UTF-16. UTF-8 is the dominant coding used in the World Wide Web. IBM had difficulty adjusting their card punch machines to accommodate ASCII coding when the ASCII first came out. And so they developed their own system. They called it Extended Binary Coded Decimal Interchange Code, EBCDIC, to be more compatible with their existing hardware. It's an 8-bit character encoding and was created extending the existing BCDIC, binary decimal coded interchange code. EBCDIC was announced with the release of the IBM System 360. When System 360 became wildly successful, so did EBCDIC. All IBM mainframe and mid-range computers and peripherals and operating systems use EBCDIC as their inherent coding. An adapter card, expansion board, accessory card is a printed circuit board that can be inserted into an electrical connector or expansion slot on a computer motherboard. They're used to add functionality to a computing system using the expansion bus. An expansion bus is a computer bus that allows information to move from one hardware component in the system to another, and peripheral devices to other components. It's a collection of wires and protocols that supports the expansion of the capabilities of the computer. A system unit is going to have open spaces built in where equipment like disk drives can be installed. These open spaces are called bays or drive bays. A drive bay or a bay is a standard size area where hardware can be added to a desktop computer. PC and compatibles have several different form factors for drive bays. The most common form factors today are 5¼ inch, 3½ inch, 2½ inch, or 1.8 inch drive bays. These names don't actually describe the width or size of the bay, but they describe the size of a disk that would be used by a drive that could be mounted in the bay. In computer hardware, a port is an interface between the computer and peripheral device. Computer ports have several different uses. They can be used to connect to a monitor, a webcam, a speaker, or other kinds of peripheral devices. There are two kinds of ports. These depend on what kind of signal is to be transmitted. There are serial ports that send and receive one bit at a time using a single pair of wires. And there are parallel ports that use sets of wires to transmit multiple bits simultaneously. USB port is a standard connection for interfacing personal computers and consumer electronic devices. USB stands for Universal Serial Bus, an industry standard for short-distance digital data communications. USB ports allow USB devices to be connected to each other and to transfer digital data over USB cables. They can also supply electric power across the cable to devices that need it. Modern multimedia applications, especially video applications, place greater computational requirements on computing systems than can be met by normal CPUs. As a consequence, most personal computers incorporate specialized video processing units, often mounted on adapter cards. These video cards include specialized processors, graphic processing units, GPUs, to deal with the specialized computation involved in controlling the images being displayed. Dedicated memory cells specifically for tracking the color and intensity to be displayed at each pixel on the output device. Video output has become so data intensive, it requires its own specialized type of transmission cables and specialized connector design. Digital video connectors are used to deliver the highest quality video signals. This technology transmits large amounts of digital data from the source to the display, resulting in a high-quality image. There are three commonly used video connection technologies: DVI, HDMI, and DisplayPort.